Okay, cool. So this is my presentation. I just put it together in the last couple of weeks. Even was working on it on the train this morning. Yeah, so my introduction, who am I? So yeah, I flew down here from Sydney. Super happy to be here because if you're not aware, Sydney is under a super thick cloud of smoke from back burning. So I'm really happy to just breathe normal fresh air for a few days. It's seriously super bad in Sydney, like it's super bad this week. But yeah, I work at Cover Genius. So one of my colleagues is here, Ali. Yep, right at the back. So he's probably our only engineer in Brisbane, I think, but we have like a few more people here outside of engineering. Yep. So yeah, working at Cover Genius. So what do we do? So essentially, we have like a whole bunch of platforms, and these platforms are developed by teams. I would describe these platforms not as microservices, but as just independent platforms, and they're quite large and complex at this stage. But yeah, we use an API-first development methodology for all of these platforms. So they're all essentially APIs, and some of them have various front ends. Each platform, it contains a certain domain of logic. So what do we do? We're an insurance company, agent broker. So it might be something to do with underwriting or claims or payments or content or something like that. We sell products to a global audience, so everything we do has to be completely global in terms of language, currencies, localized payment methods, whatever else. And yeah, we do, at this point, we have quite a lot of customers, data, traffic, whatever else, right? So this is just to give you a little bit of context for the rest of my talk. So if you're wondering why am I talking about this or that, this is the kind of environment in which I'm working currently. And in my case, I'm looking after claims, payments, fraud detection. So that's the kind of context. If you like, you can follow me on GitHub. I do have a Twitter. I don't really use Twitter or any social media, but you can follow me on GitHub. I have some packages there. Yeah, so without any more delay, this is like a two-phase talk, as we mentioned. So there's a lot of content. I'm going to try and run through it really quickly. But if you have any questions, please shout out. Every time you ask a question, I'll take a sip of beer. So give me a break and ask. But yeah.
Are these your dogs? Take a sip.
Unfortunately not. I really love Huskies. They're my favorite dogs, but these are not mine. But yeah, so yeah, some of the content I suspect some of you probably going to be aware of. Some of it might be like WTF. So hopefully it's interesting. It's essentially the kind of theme here is kind of like battle stories. So this is stuff that we've had to discover the hard way. Maybe debugging at 3 a.m. at night or whatever. So that's the kind of theme. I'm just gonna go over lots of different interesting things, peculiar things about PHP, about Laravel. We use Laravel as well as other frameworks and languages, but in my case, for my teams, that's what we use. Actually, just a show of hands, who here uses Laravel? Oh, okay, and Symfony? Other frameworks? Which is?
CodeIgniter.
The recent version? Or?
What version is it? It's we're pulling it out of 3 at the moment.
Alrighty.
Yeah.
Okay. But that's good to know. So this talk is not really Laravel specific. It is a PHP talk. However, in our case, we're using Laravel for some certain things. It's usually very much the same in Symfony. Like if you're aware, they're super similar in terms of the features they use, and a lot of Laravel features are just wrappers around Symfony features anyway. So very, very similar situation. But anyway, queuing. So queuing, that's the first of the two topics. What is queuing? I'm not here to explain that, but if you're not too familiar, usually you will have something like queue storage, the thing that's storing the job that you're queuing. You'll have a queue driver that interacts with the queue storage. You'll have at least one queue worker, that's the thing that runs the jobs. So typically your application is going to be doing things via CGI, so like PHP FPM, and your queue worker is typically running on CLI. I'm not going to bother to go into the infrastructure, but that's the context. Types of queuing infrastructure. So there's a lot of options here. So there's different kinds of storage, and there's different kinds of drivers, right? So for example, you could use for storage your database. I haven't seen anybody do this, but it's possible. You can use a cloud-managed queue infrastructure. So whether you're using AWS or Azure or GCP, they will all have some kind of queuing something. So for AWS, there's SQS. I'm not a very big fan of SQS. Does anybody actually use it? Oh, wow, that's surprising. All right. The reason I'm not a big fan, the reason I'm not a big fan is actually it's a little bit better now. So the really simple queue that they have, it used to be limited to like 100 messages a second or something. That was a while ago. Now it's, I don't know, 500 or 1,000 or something. And then the more robust one, it doesn't guarantee once delivery, which is super annoying. That's the only reason I don't like it. So in memory, that's what we use. So we use Redis. There's also Memcache. There's, I think, Beanstalk or something like that. So that tends to be pretty common. And enterprise. So enterprise may not be the right term, but like, yeah, there is RabbitMQ. That's like a whole thing of its own. It's super, super complex. Like it supports an insane amount of functionality, which is really good, but probably not for everyone. So the first point I want to make is that you don't really have to pick just one. So you could, for example, within your applications or company, you can actually mix and match. So in our case, we have a shared RabbitMQ cluster, and we use it across many different platforms, completely different platforms, not even in the same language. And the reason we use that is to kind of broadcast high volumes of data, which is going between different applications, because it just wouldn't be practical to do it via API because it's a lot of volumes of data. Like you don't really want to slow down the application by sending it through APIs. So how do you send it? Actually, this is a really good way. And it's a really good way to broadcast across multiple different platforms as well. However, in your own application, well, you can use your own queuing infrastructure, which is separate. So I guess that's the first thing I wanted to mention, which we found really useful. And they're quite decoupled as well. So there's no relationship between the two.
What's an example of a feature that's in RabbitMQ that's not in the other?
Yeah, so we use it primarily to share customer data and policies. And customer data especially is used by many platforms. And we have like literally tens of millions of customers. So it just doesn't really make sense. And those customers, they can also update their details anytime. And those details are needed by different platforms. So that kind of thing, it's very difficult to manage that across multiple platforms because then the question is who owns the data. So this is a really good way for one platform to have that ownership, or even multiple platforms can co-share that data, co-share the ownership, and they can spread changes to other platforms without really having to worry about adding new platforms. For example, it can just be done by RabbitMQ. Does that kind of make sense?
Yeah. So RabbitMQ is broadcasting it to the other applications?
Yeah, exactly.
They're not reaching out and polling for it.
That is the case in that example, yes.
Yeah. Okay.
Cool. Yeah, the second thing I want to say is have a strategy for different queues. So most frameworks, they come with a queue worker, which is fine if you're, I don't know, working on a hobby project. However, as your application becomes bigger, you really should have multiple different queues. Sometimes they're called queue names or whatever else, depending on your framework of choice. If you do have multiple different queues, you can essentially separate different concerns, right? So for example, in my opinion, even if you start with a small application, you should at least have like a fast queue and a slow queue. And if for no other reason, then it kind of forces you to think when you're writing jobs, is this going to be a job that takes a very short time to execute? So let's say maybe under a second, something like that, something like a quick API request, or is it going to be a slow job, something that might take 10 seconds, several minutes, something like that, right? So it forces you to kind of think about this a little bit, which is not a bad thing. And as your application gets bigger and bigger, you're probably going to want to introduce different queues with their own worker sets. So you might have something like a slow queue, fast queue, a queue to process batch files, a queue to send webhooks to third parties. Maybe you want to have a queue to process your widgets or orders or whatever. Queue to process emails or SMSs, Twilio integration, whatever you have. The bigger your application gets, the more it makes sense to separate out this logic into different queue workers. It's really good to separate these concerns, but it also allows your infrastructure to be highly durable, and you can kind of hone down problems without affecting the rest of your application. It also allows you to separate alerts. So for example, maybe you have a really big system, you have like 10 different queues. Maybe only one of them is doing like really, really, really critical stuff, right? Like maybe you don't care if a customer receives an email a little bit late, there might be a problem. Okay, it's not the end of the world. but there might be a different queue which is responsible for something that's like so critical that if it's a day late, then it might actually lead to a loss of money for your company, right? So it just allows you to kind of have more specific alerting around the things that are most important to your business. And yeah, it also allows you to separate out that infrastructure, like I said. It allows you to have more redundancy, and it also allows you to kind of fine tune the processing. So for example, maybe you have a situation where you need to process some batch files, and that requires like an unusually large amount of memory. Okay, so for that particular queue, when that's executing, you might want to set the resources for that, Kubernetes pod, a Docker container, or EC2 instance to something that has a lot of memory. But that may be not appropriate for the rest of your queue jobs, right? So you kind of don't want to be wasting those resources for every single job you execute. You just want to make it specific to the kind of concern that needs those resources. And it's a really good way to kind of save on money, save on your cloud hosting bills, or non-cloud hosting bills. In any case, more efficiently utilize the resources that you have. So just a really simple example. Imagine you have like a chicken. A chicken does some things like hunting. Chickens are excellent hunters of mice. They do some bucking. They can also fly, contrary to popular belief. So, all of these different concerns, you might want to have different actual worker sets for each concern. So that's what I'm talking about here. Authenticate jobs. So this is actually something that was really annoying, but when you're running in an FPM context, you might be serving people like customers or internal stakeholders that have a login to your account. And unfortunately, this session is not carried over to CLI, right? So if you're executing a job, it's not going to have that authentication. What I mean is, like, if somebody, if a user, for example, did an action that ends up queuing jobs that do other actions, you don't really have that authentication by default, or at least in Laravel. I think most frameworks. This is really annoying because number one, we kind of want to log. Oh, sorry, I thought I saw a hand. Number one, we want to log what's happening. We need it for auditing and maybe just general debugging. Like, sometimes if you have a lot of internal stakeholders, someone does something silly, kind of really helps to know who that person was. I'm sure you've had this situation before. And otherwise, even beyond that, like, you need to assess the permissions of users, right? So imagine your job is running some service code, some action, or some other job that does something else. Eventually, you're probably going to run into a situation where you need to check model policies that that user is allowed to do that thing. And in my opinion, ideally, as you're architecting your application, you shouldn't really care whether your code runs in CLI or not. It should always work regardless. You should always kind of think of CLI and HTTP as two entry points to your code. And ideally, the code doesn't really care what context it's run in, which makes it even more important to kind of carry through this authentication information. So this is one of my tips, to definitely always do that as much as you can. It is fairly simple to do. I understand you guys probably cannot read this code, but I'll just very, very quickly explain. All it does is it's like a middleware for a job. I think most job drivers have middleware, and the trait on the other hand. So a job will have a trait sets the middleware. All that happens is when you initiate a job, it grabs the authenticated user, saves it in the job data. When the job runs, the middleware logs in the user, executes the job, logs the user out. Very important to log the user out, as you will learn later on, but that's all it does. It's very, very simple. It's a very simple paradigm. You can implement it yourself in like 1 hour, I'm sure. Transactions inside jobs. So very, 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 very annoying. Why is it annoying? In Laravel, it just so happens to be the case that the process, which is the worker process, it does not spin up a new process like Linux process for every job. It just executes them in the same process. There's actually some code in Laravel. I don't know if you guys have ever seen it, but it's like, if we've run out of memory, kill the process, and then we just rely on whatever else to restart the process. So it'll automatically restart every now and again. But until that happens, it just executes every job in the same process. What that means is if you have some, I don't know, let's say buggy code or some weird situation where you have a transaction that's loose and you didn't close that transaction will actually carry through to the next job and the next job and the next job, which is super, super annoying. And in our case, there might be like 1 or 2 jobs which are so critical that if this happens, it's like an absolute catastrophe. So a really simple thing that you can do to, it's kind of like defensive programming, is you can have something like a function which runs down the transactions until you reach a transaction of 0, which is this example here. All it does is, look, if there's a loose transaction, you just commit it. Maybe you want to not commit it, maybe you want to roll it back. Doesn't really matter. The point is ensure transaction level is 0 before you start the job. That's really useful, especially if you're working in a team. Like, you don't know what other people are doing. They might inadvertently introduce a bug. You don't want it to lead to problems for other jobs, for unrelated parts of the code. So that's something I found really useful to do. Had a lot of fun debugging this one. Unreported exception pattern. So what is this about? So again, in Laravel, if you're executing a job, like you typically have some amount of job retries, let's say 3. Okay, if that job throws an exception, that job will get retried. However, that exception also gets reported through error recording, which means, for example, if you use Sentry or whatever else, if you have it integrated with Slack or email, you get 3 alerts, which is super annoying and useless, in my opinion. So this is like a very simple pattern that I came up with, which is, okay, if you're throwing an exception, do it as an unreported exception, as in make a new exception to encapsulate the actual exception. This works only if you do a try catch, obviously, in the job. And then when that gets thrown, yes, still the job is considered as failed. It'll be retried, so that happens as normal. Then once the job fails for the last time in the failed function or whatever else, whatever error handling you have, okay, then you can get the actual encapsulated exception. And if you like, then you can actually record that through to your error handling. It's just like a very simple thing that saves essentially like exception spam if you don't want them every time.
How do you retry your jobs in Laravel? Because like we use SQS and we just rely on the fact that the worker doesn't delete the message from SQS and then SQS automatically like retries it again. Yeah.
So the framework queue driver will automatically retry it. I think very similar. So you don't necessarily have to do anything. You can kind of manually intervene if you want to, but by default, the job fails. It gets put into the queue again, gets tried again, and as long as how many ever retries you have.
So that's Laravel like try catching like deep down in the stack.
Exactly. Yeah. Exactly. Yeah. That's exactly what happens. That's right. Cool. Infinite retry pattern. So on the other hand, there might be some jobs which are so important, you basically never want to fail it, right? You want to say, no matter what's happening, no matter what the problem is, maybe it is the case that, let's say 80% of the time, the problems might be temporary or fixable or addressable. And you don't want the job to fail because you don't want to have to then manually rerun it as an engineer. You don't want to have to, SSH into the server or Horizon or whatever else and say retry the job. So in this case, okay, you can have a different logic where you essentially just pick up the fact that it's the last iteration of the job, as in the last attempt. And then if that's the case, if there's an exception, okay, just queue it again. Like queue it again, very simple. If you do this, like hopefully, ideally, you're going to have some kind of a back-off algorithm, because if you don't, you're going to flood your queue worker with failed jobs, obviously. But yeah, it is a very simple pattern that's really useful. It's probably not for most jobs, to be honest. But again, there are some situations, like for example, we have one where we have a lot of problems with a certain third party. So if there's a certain kind of set of problems which we detect, we know for a fact that it will succeed eventually. And we don't want to fail the job. Doesn't matter if it's failed 10, 20, 100 times. Doesn't matter. It's going to succeed eventually. So we just infinitely retry it. Kind of useful sometimes. Okay, some questions.
Sure.
Some laughing.
What did it say? You go ahead.
No, please go first.
We had the same problem just the other week in our queue. So we had this with a retention job. There was a bug in the code and the queue was not. We were doing it in a SQL backplane, and the queue kept adding to it but not deleting from it.
Yeah.
So once we fixed the bug, we created like an infinite retry pattern to successively go ahead and keep deleting. And if it times out the query time, because you can't delete 10 million rows at one time. So you just definitely back off and try to do one row at a time till it's able to get it under control.
Yeah. So yeah, many such cases. Do you have another thing?
Yeah, I do have a different one. So with this infinite pattern, I guess it would depend on the type of job. Because if it's a really important update, for example, and it's infinite, so if it fails, and you're like 3 hours down the track, and someone submits a new update to the same entity,
Yeah,
and that one
yeah.
processes while yours is still waiting.
Yeah,
And
yeah.
that would it override it back, or would you have to have more checks in place to protect it?
I think in this case you would. It's really good for things which are, I can't pronounce this word. Idempotent. Yeah. So if it's a task like that, that's just definitely not gonna get replicated or stuff up the status of something else. Totally safe to do this. If it's like, let's say if it's a user on the front end that's saying, oh, I want to do this, and it's an action which takes a long time, and they essentially queue the action, then somebody else comes along and says, okay, now I want to do this. Okay, that's a situation where this can go very badly. So you just have to kind of use your judgment, because obviously it's not for everything, but it's for kind of tasks, usually, especially with third parties, unreliable third parties, which that you don't want to have to manually deal with, and you know they will succeed eventually. I'm sure there are many other use cases like the one you described, but yeah, you just kind of have to have a think, like, is it the right use case for that? And if you do have a collision, like the status collision, update collision, okay, how do you deal with that?
Would you try to do like some sort of temporary row lock until?
Yeah,
that
so
infinite queue
I was about to
is
say locking is probably not a good solution for this, or at least cache locking. You can use like a longer lock, maybe something in the database, because you don't want the cache to be cleared in between when you take out the lock and when it eventually happens. So you have to be really careful, but it's ideal for those things which definitely nothing else is going to clash with, I think. Yeah.
Do you then have some sort of alerting, so like if something has been retried like
Yeah,
times,
yeah.
like you get pinged about it, so you
Yeah. Ideally, like if there's something so important, probably you're gonna have it in the dashboard. Funnily enough, we don't, but we really should.
But then how do you stop getting the spam, the alert spam, if you're in an info?
Oh, we definitely don't get alerted about this.
No.
Doesn't sound like a problem waiting.
It has been amazingly reliable. I think there may be some alert if it's retried like 100 times or something. I don't know. I think there's something like that, but yeah, you should have something like that, because otherwise you might have sometimes I might look at a certain queue and it has like 10,000 things in it. I'm like, oh shit, 10,000 things in the queue. What's going on? Actually, they're just things that are doing this. They're nothing. There's no.
That's no big deal.
It'll work eventually.
It'll work exactly. It'll work eventually. It'll work eventually.
And if it doesn't, the company will fail, and you don't have to care.
Exactly. Pretty much. So yeah, look, you can get some funny things with it. Just again, use your best judgment. It's not the most trivial stuff. I think if a framework introduced a function like infinite retry, I'm sure there would be so many problems from that. They'd probably remove it immediately. So use your best judgment. That's all I can say. Yeah, speaking of job failure, so this is something that's super annoying. Again, something from Laravel, maybe the same in other frameworks, in other drivers. In Laravel, there's a concept of a failed function. So if a job failed, it calls that function, right? Now, it might be really, really nice if you could, in that function, use something from the computational results of what happened in the job from the handle function. Unfortunately, what happens is it actually instantiates a new instance of the job. So you run that failed function, which means whatever happened in the job, you don't really know about it. And there's no easy way to get that result, those intermediate results, which you might want, which is super, super annoying. And it may even run in a completely separate process. It may, like if you have multiple queue runners, it might run in a separate pod in a separate container. There's no way to guarantee it runs in the same one, I think. So if you want to pass data to it, ideally you can use job payload. One thing we've done in the past is use static data. So actually maybe it does run in the same process. I can't remember. But the process can always crash, so you have to be careful. So ideally you should pass things in the job payload if you need them in the failed function. And it also will be outside of a transaction, because the transaction hopefully will be closed by your job. That's just a small one. Yeah, visibility timeout windows. This is a very simple concept. It's super important. Every single queue system out there has something like this. They call it different things, but basically whatever timeout you have on your queue connection, on every job that you have, whatever else, all of them should always be smaller than whatever is the visibility timeout window. And all this means is that when your worker consumes a job, the queue storage, the queue driver makes it invisible for this period of time. So the really obvious thing is if you have a really long timeout, which is possible for a queue job, if you have a really long timeout, if it goes longer than this visibility window, it's going to get queued again, which might be a really big problem for you. So just be really careful with that. Try catch with a job. Yeah, so this is a really, really interesting one. I only found this out maybe even earlier this year, but so imagine you have a job like this. Is that kind of visible? Yeah. All right, cool. All right, let's say you have an SDK. SDK creates some kind of widget, some kind of products. It's a third party, right? So the SDK is instantiated here in the try block. We're just using the SDK. We're saying, okay, create widget with the data. It does an API call to the third party, right? If it fails, okay, we'll log the message, and maybe this thing is like part of a wider set of things that we're doing. It's part of a bigger operation. So it's one of 10 jobs or 5 jobs. And so when this finishes, we want to move on to the next operation. Whether it fails or not doesn't really matter. We know we want to execute all these things, but I don't know, maybe we want to do them in order or something. I'm not sure. Doesn't really matter. Maybe this is just to tie up and check if every job is finished, run something else. But we want to definitely do something in the broader context of what this job does after this finishes, regardless of whether it succeeds or fails. So my question to you guys is, can you guess what is like a really big problem with this? Yes.
There's no try catch around next operation.
Oh, this one.
Yeah.
Don't worry about that. Imagine it used another job. Never mind that. Unfortunately, there's a less obvious problem. Can anybody guess?
Operation doesn't know if it failed or passed.
Yeah, but that's by design. That's fine.
I'm scared of this code
Don't
base.
find bugs in this code.
Okay, so all right, imagine you're an engineer and you're trying to debug this situation, and you have, let's imagine there's 5 jobs that execute. Yeah.
You swallowed the exception, you haven't thrown it yet.
No, not that. Although that's a good point. But in the context of this example, that's actually a really good point. However, ignore that.
Right.
Ignore that oversight on my part. All right, so imagine you're an engineer, you're debugging this, but this thing, you definitely know this job executed. 100% you know it executed, but this thing never happened. What's in this file? Like imagine you put a log here. There's no such log. It never executed, but you know that this executed 100%. So can you guess as to why?
The only thing I know about finally is that if you have an exit call within that try block, then it doesn't go down to finally.
I think you're right, but that's not it. I'm gonna give you a hint. It has to do not with this, but it has to do with this.
If the process took too long, I timed out.
Exactly. So PHP is really funny in that it guarantees that a finally always gets executed unless you exit the script. This is true. However, there's no guarantee that the job process will not get killed before that happens. So, and this is actually not that uncommon as you might think, because typically we're doing some kind of API call, some kind of long running things within a job, and jobs have timeouts for a reason, right? The timeout exists for a reason because it is a very conceivable thing that a job times out. If a job times out, essentially what happens is the worker process will do like an interrupt to kill that process, kill that whole job process. It's not going to care about the fact that there's a finally here. PHP cannot do anything about it. Like the whole execution of the script dies. So this is really, really super annoying because it means you can actually have a situation like this where this executes and the finally never executes. And it's super annoying because there's very little you can do about it. So look, my advice is just understand that it's a thing that can happen. Ideally, if you have, let's say, one API call, okay, that's a bit of a luxury because you can just set a, hopefully you can set a timeout on the SDK. You can set a timeout on Guzzle if you're using that. And you can make sure that that timeout is smaller than the actual job timeout. You can make sure that never happens. If you're doing multiple things in the try, man, you're a little bit shit out of luck. But yeah, look, just try and not rely on a finally too much within a job context. Try and do everything that you can somewhere else in some other way. Yeah, that's really the only advice I have. But it's a very interesting problem to have and debug.
You can, depending on your like queue infrastructure as well, request that the visibility time gets extended again. Like we have that where there might be like a chain of these long things together and you come back after like 45 seconds, you're like, all right, give me another 60 seconds. I'm not dead yet.
Yeah.
Let me keep going.
That's a really good idea, yeah, for sure. All right, what's happening? Okay, we're progressing. Okay, common traits for jobs. So this is really simple. If you have a lot of jobs, it might be really useful to have a common trait for jobs. And it might be really useful to do things like set a default timeout. You might even have a function that's like a timeout setter, which makes sure it's not above the config visibility timeout. You could have helper functions to, again, ensure all transactions are rolled back. You can have authenticatable trait and middleware, like what I've already showed you. You could potentially have some testing helpers, infinite retry logic. You can set other properties like max exceptions, max tries, like whatever defaults you want. And yeah, but that's just a really good thing to have rather than have like a lot of boilerplating in every job. This is kind of less technical, but it's more for, I don't know, engineer quality of life, let's say. So yeah, in my opinion, this is something, or in my observation, this is something engineers and dev teams don't really ask themselves enough. But you know, what happens if a job fails? Whose problem is it? What are you going to do? You know, you're building a system. You might have some jobs. Some of them might fail sometimes. Imagine your business grows. You have more stuff happening. You have more, you know, customers, products, widgets, clients, aliens, or whatever. So the obvious thing is you cannot scale your ability to respond to job failures just because there's more stuff happening in the system, right? So just as a bit of advice, so in my opinion, it's a little bit opinionated, but in my opinion, for every job you have, you should kind of have a think. What happens when the job fails? And it should be ideally, if possible, one of these two things, not both, but one of these two things. Ideally, email the business stakeholders if it's like if it's not a technical job. Like there might be some things like, I don't know, you're refreshing currency rates. Okay, nobody cares if it fails. It's your problem to fix. Maybe you don't care either because it's fine for it to fail once in a while. But ideally, if it's anything to do with a business operation, whatever it might be, email whichever business stakeholders might be interested in this failing and let them fix it, right? And you have to empower them to fix it. You have to make sure that they can log into your system, they can inspect why it failed, they can retry the job, they can contact the customer and update, I don't know, whatever details, whatever the situation may be. But ideally, it wouldn't be you. It wouldn't be you, your team, working to fix the problem that caused the job to fail, right? Ideally. But for some jobs, okay, it may actually be sensible to just report it to your exception handling and have the engineering team to investigate. But you know, what I would say is always, like when you see this thing, when you see jobs failing, always look at every single error and if at all possible, try and architect your job. So if it's a known thing that fails, if it's a known exception, known problem with a third party, intermittent problem, whatever else, try and deal with it. Try and ideally steer it towards something that's fixable by business people, not engineering people. So you don't really want to be wasting time fixing failed jobs because they fail for expected reasons, right? So as I say, and I very, very strongly feel about this, but exceptions are for exceptional situations only. If it's something that happens, it's not exceptional, right? If you know it's going to happen at some point in the future, it's not exceptional. It's not an exception. You know it's going to happen. So, okay, there should be a way to deal with it automatically, which ideally doesn't involve the engineering team at all. And that can help you scale your business very well. Queue worker scaling. So this is
Do you have like a logical place to stop? Like,
there is, however, we can just stop here. It's fine.
if you're
Yeah. I appreciate hot pizza, so yeah.
All right.
let's have a bit of a break then. For those online, we're just going to have a bit of a break for pizza. Probably be a bit of a shit experience for you. Maybe go have dinner. But we'll be back soon.
Yeah, all good. Yeah, so guys, we're about like 45% of the way through, so do apologize if it takes a while. But all right, so queue worker scaling. So, you know, previously I've said it's really good to have different sets of queue workers, one for every type of queue that you have. So like fast, slow, whatever else. Equally, it's really good to be able to scale your workers. And ideally you would use some kind of horizontal scaling. Oh man, I think, yeah, horizontal scaling. I did get that right. Yeah, on a per queue basis. So essentially, if there's too many jobs in a certain queue, okay, you scale, you create more queue workers. Usually this happens due to increased traffic or potentially a batch process, or maybe like, I don't know, a neighboring platform has a batch process that results in a lot of requests, so something like that. It's not too difficult to do, though it's not too simple either. You just have to report how many jobs there are in each queue, ideally by the minute. Also, this kind of fails down if you have a lot of, queues in like a back-off algorithm, but ideally that shouldn't be the case for most queues. So for example, in our case, we use Kubernetes, and it's really simple. You just report the number of items in each queue as a Prometheus metric. Prometheus is just like a learning and monitoring kind of system, if you're not familiar with it. So you just report a metric for every queue, and in Kubernetes, you can actually scale just based on a Prometheus metric. It's pretty simple. So that's one way to do it. The reason I mention that is it's usually not that useful to scale based on like usual CPU memory. And the reason is, even if your queue is kind of processing a lot of things, you probably want to adjust it so that it's using the appropriate amount of CPU and memory, so it might not look abnormal, even though there might be a lot of jobs in the queue. So it is good to use that as a metric rather than the resources used. And yeah, this is what it looks like. So the previous chicken worker or chicken application. So imagine that your chicken decides it needs to fly a lot suddenly. So all right, we spin up more short flight workers. Pretty simple. Yep, so we're getting towards the end of the queue stuff. So this is just like really random small facts that don't deserve their own slide, essentially. So yeah, oftentimes when you're queuing, you want to do it with a delay. Some queue drivers like SQS actually can do this by default with every job, but it's a good idea to do that. Alternatively, for example, in Laravel, there's a kind of new, not that new, but newish feature where you can say queue a job after transaction. So it waits until the whatever current transaction is finished, then it queues it. Really useful. Because if you're doing something that's the queue will require, the job will require in the queue, it's really good to kind of complete that first. Yeah, sometimes chaining jobs is a good idea. Again, something you can find in Laravel, where you can chain job after job after job, so that if one job depends on the one before, you can actually chain them and explicitly state those requirements. If you don't have that, well, you can just manually do it. It's not such a big deal, but it's really useful for event systems or just in general if you have dependencies across tasks. Yeah, also queuing, it is very important. If you have something like a health checker endpoint, maybe for your load balancer, ideally you should put something like just queue an empty job there, so that at least, like for example, if you can't connect to your queue storage, at least that will get picked up there. Yeah, more best practices. So think about job overlapping. Like for example, something we discussed already, which is imagine you have queue jobs to update the status of something. You could have a situation where you might have multiple of them happening at the same time. So it's possible to do this manually or automatically in Laravel. There's a middleware for overlapping jobs, or you can just use like a cache lock. Consider out-of-order job processing. So for example, imagine you're queuing webhooks from like a third party, and let's say they unexpectedly send you a whole bunch of webhooks because maybe on their ends you go across, I don't know, 3 statuses instantaneously. If you have multiple workers, they may process them out of the order in which they actually happened. So just consider this kind of scenarios when you're doing your work. You should restart your queue workers ideally every X job executions. If you have something like Sentry or Bugsnag or whatever else, if you ever see an exception and you just see like a whole bunch of binary characters and you're wondering what the fuck is going on, the reason is you've had something like a memory leak in PHP, which is a thing that happens. In fact, so I would go further, it's actually inevitable. If you have a queue worker, it will inevitably have some memory issues at some point. The more job throughput there is, the more likely it's going to happen sooner, right? So ideally, you should restart the queue worker every X job executions. So I think in Horizon, this is actually a setting called max jobs, which is really useful. So you can set it to like 100, 250, 500. No issues with that. If you don't have something like that, you can just have something to restart to kill your queue worker every minute, every 5 minutes. I don't know, whatever you feel is appropriate. But ideally, it would be based on the number of job executions. Because again, if you have a queue worker that's doing like a huge amount of throughput, it's really difficult to tune that by a period of time. It's much easier to do it by the amount of jobs that it has executed. Another thing you can do if it's within the same process, well, you can use something like a static global to track how many iterations there are, and you can just kill. It's very, very hacky, but like if you really need to solve this problem, you could do it that way. Just kill it after X amount of executions. Yeah, make sure you have PCNTL installed. It may seem obvious, but like one of our many projects, there was a situation where we weren't yet using Horizon, and the queue worker just like wasn't executing anything, even though it seemed to be running fine, seems to be no problem. What had happened is some job, maybe, I don't know what happened. It should have timed out. It should have been killed. It wasn't killed. For some reason, it stuck around, and just nothing happened. It was super annoying. Like, why? How? Because this PCNTL wasn't installed. There was no error. Just couldn't kill the job. Yeah, use exponential backoff. So exponential backoff is one of my absolute favorite things. Goes really well with the infinite retries. So if you have a job that you know it's probably going to work, if your third parties have intermittent failures, it's great. Back off for a minute, 5 minutes, 15 minutes, an hour, a day, a week. Hopefully not a year, but do that. It works so well in so many scenarios. Yeah, log generously. Don't forget to log. It's really useful for debugging. It's kind of obvious, but yeah. Performance. So yeah, if you're logging non-local, if you're logging to non-local channels, so for example, let's say you want to send a Slack notification for critical exceptions. Don't log it within the synchronous process that you're running. Do a queue job, which is essentially a wrapper for a log, which logs to Slack. I don't know if that makes sense, but what I'm trying to say is if you do a log to Slack, there's obviously a TTL that you have to wait from Australia. I don't know, maybe like 300 milliseconds, or maybe they have an Australian server now. I don't know, but you don't want to do that. You don't want to do that. Not in your not in CLI, but certainly not in an HTTP request. So instead, just have a job which logs to Slack, right? If you want to log something, instead of logging it, run that job instead. With your jobs, don't overload them with synchronous operations. Stick to the one job principle. And the reason is, yeah, and this is something I see developers doing sometimes, is that they just kind of treat jobs as a dumping ground for slow operations. It's very easy to do, especially when you're kind of building out your application. But just, keep in mind, jobs are not that, like, they don't have infinite resources, so you should still, chunk your selects or whatever database operations. You should use streams to read CSV files or whatever else. You should monitor performance through APMs like New Relic. It is really important that you keep your jobs relatively simple, relatively neat. If you have a lot of things going on, consider having a job that just gives another job, like split it up as much as you can. And yeah, and another thing is, so it may be really useful for performance, not of the job itself, but if you have automated testing, and if you have a complex platform, it's quite likely you might be queuing a lot of things during operations which are tested. So you can have a concept of jobs which are just like not executed, or maybe they just return straight away for testing. So you can consider doing that. They can speed up automated tests significantly if those jobs are not necessary during those tests. You can also do like some more complex stuff, like you can create doubles for classes that queue things, like a certain service or something like that, and you can say, okay, I'm not testing this thing right now. Don't do anything, right? So very, very similar, but that's more of a testing talk, so I won't go into that. All right, that's everything for queuing. Fairly quick. So this section is not as big, hopefully. At least it was very small until I wrote a whole bunch of slides 2 days ago. Yeah, so this is split into 3 things. And essentially, this is everything that's asynchronous in PHP, which is not a queue, right? That's the way it works. So WebSockets, I won't say much about WebSockets. All I would say is that you probably, at some point in your application's lifetime, you should probably begin to use them. To me personally, this is not the only use case, but to me personally, if nothing else, it's really, really good as an addition to your UI. If you have some kind of stakeholders, maybe in our case, internal stakeholders, they do some operations, they take a long time. It's really, really good to give them that feedback of when that operation finishes. It could be because they're waiting on it to do something else. It could be because they need to know when, I don't know, certain file is processed or whatever else, when the status of something is updated. It's just really, really good for usability. So it's really good just for this reason alone. But there's also, you know, many other situations, especially with end user customers. Yeah, and especially good if you do have these long-running API requests, especially if you have API requests that queue things and whatever else. It's really good to provide that feedback back to the end user. Something like this. You may know Pusher. Does anybody here use Pusher? Oh, that's surprising. Okay. Does anybody use something else?
I've
That's
used
like,
it in the past.
Yeah, technically.
all right. Maybe that's my next slide. Yeah, but WebSockets is pretty simple. Like, you just need something to be the intermediary. The browser, which is of course your front end, or I don't know, maybe a mobile app, and then your server is the thing that's either receiving or sending things to the thing that's providing the WebSockets functionality. So I was actually doing a little bit of research because we need to add this to one of our applications. And yeah, in the past I've used Laravel WebSockets. Apparently it's kind of fallen out of favor. And Laravel Echo as well is something that seems like people don't recommend nowadays. In fact, I've only found one thing which is apparently really good, which is called Sockety. Is that what you use by any chance?
No, I use Amply.
Damn it, I have to write this down. I'll have a look into it. Yeah, but if you haven't heard of Sockety, apparently it's this whiz-bang. It's kind of like the RabbitMQ, but for WebSockets. If I was to use an analogy, it's like a really, really proper WebSocket server. It's really fast. It's extremely scalable. It's very reliable. Everybody's banging on about it, like it never fails. I don't know. Apparently, it's the cool new thing. But it's a little bit complicated to set up. Well, not complicated, but it's a DIY hosted solution, which is actually one of its main proposed benefits, is that it's much cheaper to run for the amount of traffic that it can process, if that makes sense. But it is compatible with the Pusher protocol. So for example, if you already use Pusher, or maybe you just want to get started, you can get started with Laravel Pusher. You can just swap to this. Your application code doesn't have to change. But it is a little bit extra effort infrastructure-wise to set it up. Anyway, scheduler. So this is, yeah, schedulers are crons. So Laravel has a scheduler. I know in Python they usually just execute commands using Linux cron jobs. I don't know, does Symfony have a scheduler? Yes. Okay. That is good to hear. So maybe this will be very relevant for everyone. So here, I'm just going to take you through the same or similar number of commands, and I will just like add a few things to it. So imagine you have a whole bunch of commands. This is something we were discussing like literally a few weeks ago, because one of our platforms didn't do this, or it may be 2 slides in, but I was like mortified. I almost had a heart attack when I realized this. But anyway, so this is essentially executed by the scheduler. If you don't know how the Laravel scheduler works, you might be able to guess, okay, it's a process. It's hit by a cron job, like a Linux cron job, every minute, something like that. And then that process, it spins up other processes to execute each individual command. Well, theoretically, by default, it doesn't. It just executes them synchronously, right? So if you have something like this, actually, the point of my next slide is, if you do have something like this, like we tend to want to execute things on even intervals, so like hourly, by the hour, on the top of the hour, something like that, maybe half hourly. I would say if you don't really care when it executes, but you just want it executing hourly, try and avoid doing this. The reason is you're bunching up a whole bunch of scheduled processes into one block, and it's just not a very good way to do things. Like if one of them takes a long time, if there's a failure, or otherwise, you're just bunching a whole bunch of operations into one minute window across the hour. There's no real reason to do this unless you specifically need it to be happening at that hour. So if you are adding something like this, the syntax doesn't matter. Like you can use the cron syntax. Obviously, this is just for syntactical sugar, but try and just pick like a random minute, just to use your brain's random number generator, or maybe a website, maybe a bit better. But just pick a random minute, run it on that minute, right? If you want something run hourly, you don't really care when, do this. It's much better for your application's overall stability. And yeah, essentially, I just call this implicit load balancing. all it means is that don't pick like, hour 00 of the day. Don't pick minute 00 of the hour. Pick something random unless you need it to happen at that time. And yeah, this will implicitly help to load balance workloads, and it'll make resourcing the scheduler an easier challenge from an infrastructure perspective, right? Because you don't want to have a situation where you're running like 50% of your scheduled workload 1 minute out of the hour. Like imagine trying to figure out what the infrastructure for that looks like. It's obviously not going to be very optimal. Yeah, so back to this. So yeah, how can we improve this? What else is it missing? Yeah, so this thing. So in Laravel, basically, this is the thing that you need in order to run it in the background, like the Linux ampersand. So it'll start up a new process. If you don't have this, what happens is the scheduler just synchronously executes every single task. And what's the problem with that? Well, some of these, they may be quite slow. They may take seconds. If you have a whole bunch of them, if you have 30 things in your scheduler, it's entirely possible that the last few commands, they're going to drift quite a lot from the initial time at which they're supposed to execute, which is potentially very, very bad. So we don't want that. There's no reason not to do this, as far as I know. Always try and do this. Yeah, that's actually just everything I said. Yeah, avoids cascading effect of, one task slows down, the next task snowballs and snowballs and snowballs. Not very good.
Does anyone know why you might want to run it in the same task? Because Symfony only just released their version of this, like in the latest version. And from what I saw, it's the same. Like by default, when you schedule something, the scheduler task is just executing everything one after the other instead of like dispatching it to a background job to do.
Yeah.
To keep the system load more even on the con server.
Right,
So
because
if
if
you've
you've
got a
got
smaller server and you've got several really heavy jobs that are all scheduled for the same minute, you'll do just one and then the next one, then the next one, rather than background process, the system load goes mental and everything slows down.
Also, I guess like some people wouldn't be running queues either. They want the scheduled parts and they just want to cron tab on their like one handmade server.
Yeah, sure.
Yep. And to avoid that problem, again, split out your scheduled tasks that don't run on the same minute, all of them. So yeah, what else can we do? So ideally you will have, well, sorry, not ideally, you might have a situation where you're running the scheduler on more than one server. In Laravel, there is a thing called on one server, which makes sure it only runs on one server. So we don't do this now because we use Kubernetes crons. However, in our previous infrastructure, we actually kind of bundled all of our queue workers and the scheduler into one Docker image, which means you might have multiple of them running at the same time. Definitely not a good infrastructure pattern, but it's a really good thing to do this anyway, just in case, like you never know what's going to end up happening with your infrastructure. And yeah, also Kubernetes crons, they're not, I wouldn't say they're like 110% reliable. Sometimes they do some really funny things, like they might just start a little bit late for some reason. So just to help prevent overlapping, it's not, well, actually there's also another thing called no overlapping, but anyway, it's a good idea to do this in my opinion for the scheduler. Yeah, once again, I don't know why this isn't the default. I can't imagine you would want multiple instances of the scheduler running, but I don't know. Yeah, and the other thing is send output to. So again, in Laravel by default, I don't know why, but it sends the output to dev null. I'm not sure who thought this would be a useful thing to do, but it is way more useful to have it sent somewhere. In our case, if you're running Kubernetes, it's really good to have like a login sidecar container, which just takes standard out and pipes it to wherever you want. Like, for example, Kibana. Well, not Kibana, but like Elasticsearch. But you cannot do that if you have no output, right? So I always try and make sure everything logs to standard output. And I think that's actually it for that. Any questions on that?
That's a lot of extra work every time you want to schedule a job.
Oh yeah, and there's even other stuff. Like I think they have middleware now. There's all sorts of crap. So this is just like it's actually even not that much. In some of our platforms, we actually have all of these on like a separate line. There might be like 10 lines defining what the command is, the intricacies of what a command is supposed to do. So I don't know if it is what it is. They're useful features.
I think Laravel 7 or level 8, you can actually
send a schedule command into a queue worker.
Yeah, that is, yeah.
Like for us,
Which is what you should be doing mostly if you've got a
Yeah.
queue.
So,
You almost never want to be running the command on the server that is running the scheduler.
Yeah, actually, maybe that's another good point that's not in my presentation, but that's really good feedback. So yeah, if you have something that you know is going to take forever, yeah, why on earth would you run in a scheduler? It doesn't really make sense. Just queue it up inside the scheduler.
also for like fails and retries. You get that.
Exactly. Yeah. All the same problems.
Visibility.
Yeah, like all the problems of queuing are solved in queuing, but they're not solved for scheduled tasks. So ideally, this should not be very, very complex.
imagine running like a 4 gig, 8 core server schedule.
Cool. I have no idea what the context of this is. Yeah,
Makes sense to me.
I think it's like running jobs in parallel. or something.
maybe. Something to do with scheduling your jobs. I don't know. I need to work on this slide more, I think. Cool. Logging execution of the scheduler. So yeah, this is also really useful because schedulers can break for whatever reason. I don't know why, but it's possible. It's happened to us. Can't remember why. So what we do is very simple. So we use Prometheus, which I think I mentioned, to report custom metrics, and we just have like a very simple schedule task. I think it's like the very last thing. It's purposely the last thing in the scheduler. It probably shouldn't be running in the background now that I think about it, but regardless. So if everything has executed or has begun executing, at least this will execute. And all it does is just sends like the thing that it's happened to Prometheus, and it knows that it's happened in that 1 minute mark, right? And then we have like one of the widgets in our Grafana dashboard. It just has the scheduler, minute by minute. So if there's a dip, so we know, okay, something must be wrong. So it's just a really good thing, to like a quick thing that you can have in your infrastructure dashboard, that if it's not there, like, immediately something's wrong. Cool. And I think this is the last, this is the last topic. It's also kind of, in my opinion, the most interesting one and the most theoretical. So prepare to have your minds blown. So synchronous IO, it's very slow and it's blocking. It's a problem that's plagued PHP since the dawn of time, or maybe like, I don't know, the last 10 years. I'm not sure. It was probably not a big problem initially. But yeah, asynchronous execution. So has anybody here actually done like Node.js or even front end? Like on the front end, obviously it's the same thing. So you probably have some idea about how this works in JavaScript. So obviously async execution saves quite a lot of time. It allows us to utilize CPU resources more efficiently. In the case of PHP, it allows us to utilize workers more efficiently as well. There's quite a lot of solutions for asynchronous programming. It has been around for a while. It's not like a completely new thing. So these days, I think it's easier than ever. So Guzzle does this out of the box. Anything that Guzzle uses, so Laravel has an HTTP client. It's just like a wrapper around Guzzle. So it also has its own syntax for it. It's very easy to do. I think that's it there. I think most frameworks and libraries have something like this, right? So yeah, the idea is that if requests don't need to be done, the other thing is, so if a request doesn't need to be done within an HTTP request, obviously, you can delegate it to a queue worker. That's fine. It also doesn't really negate the need to do this, because if you think for a CLI script, it's actually even easier to do this, right? That's probably where you're going to be doing it, and it'll save on the execution time of that job. So it's really important to do. Oops. But yeah, so the question is, do we still need to optimize queued calls if we don't really care if we just queue it? So the answer is yes, we do, because we don't want a situation like this where you have a queue worker where you have to queue multiple things to execute multiple commands. It is really good if you can have one worker, like if it's one item of work. Like for example, let's say you want to send webhooks to some consumers for one action. Like, you know what the action is, you know what the consumers are. You could queue a worker for every webhook, or you could just queue one worker and send them all in parallel because you know everything you need to know in order to do that, right? So that's kind of more ideal. You're going to be using your infrastructure resources more efficiently. Plus, it's like way more interesting to program. Pulling HTTP request to async. Yeah, so just trying to remember my own slides. If you're the one that's making HTTP calls, okay, so it's always better to pull them together. Yeah, even though it may or may not slow down your application's request response, as I just said, it's still going to save resources. And just keep in mind, by default, doesn't matter where you're running your script, by default, PHP will always block any I/O. So it wastes available processes or workers, as I said. Otherwise, they might be free to do something else. The worst thing is if you have to, like, for example, scale your queue workers, but they're not really doing anything. They're just waiting on I/O. All right, so getting to the crux of one of the things I wanted to discuss. So it's really, really good, very easy when you control the calls that are being made. But in reality, a lot of the API calls that our applications do, we don't really control the code that's doing that. And the reason is very likely it comes from like a third-party library. Common use cases, maybe you're sending emails, you're probably using something like, I don't know, SendGrid or whatever else. Twilio for SMSs. Maybe you're doing payments, so you might be using Stripe or PayPal or whatever else. Maybe Crypto.com. I'm not sure. But most of the third parties, the luxury that we have as PHP developers is that we don't really have to integrate with most third parties. There's usually an SDK for it. Even if the company themselves don't have one, probably there's one on GitHub, which is good. However, imagine you have this problem that you actually want to run multiple of these requests in parallel, but you don't really have control over the underlying code. So what do you do? What do you do in this case? Does anyone know? I'd be very curious. Okay, so there's many packages and projects to tackle this. So there's one called Spotty Async, which somebody was telling me about a couple of months ago. I had a look. So nowadays, both Symfony and then, of course, Laravel have their own abstraction of processes. I think they work exactly the same. There's a lot of syntactic sugar around it. But yeah, so that's fine. But each individual thread, it'll still block when the request goes out via the SDK. That is to say, the SDK itself is not asynchronous. That code is not asynchronous. My point here is, man, it would be fantastic if engineers who write SDKs engineered them to work in an async fashion. Even if you had maybe two sets of functions, one which is, I don't know, traditional, legacy, whatever you want to call it, and like an asynchronous version, or maybe like a flag or something. I don't know. It would be amazing, I think. I have not seen this happen anywhere, which is very annoying. But man, in my opinion, it would be amazing if there was like maybe a PSR standard for a PHP SDK, which does API calls to do non-blocking I/O, right? And then every SDK developer over time could adopt the PSR or adopt the standard or interface or whatever else. How we can do this, I'm not so sure, because libraries, they might use very different tools to make API requests. So right now in our projects, I know for a fact there are SDKs using Guzzle, which is probably the most common, but there's ones using curl, unfortunately. There's ones using sockets. I don't know why, but it is a thing that it is a thing which is somehow still a thing. So how do you standardize SDKs across so many different libraries and tooling for sending requests? I'm not sure, but it would be amazing if somebody did this. So I don't know, maybe somebody here wants to write an PSR standard for it. I will support you if you do that.
Have you looked into finders?
Yes, it may be mentioned later on in this talk. Later on in this section of the talk. So for example, back to Spotty Async. So this is kind of how it looks. If you use Symfony processes or Laravel, I don't know, whatever it's called, the same thing. It looks almost the same. So you can add any logic here. You can add SDK logic. Again, it'll still block at the SDK level, but you could pull multiple SDK calls, third-party code calls inside of this. Add it to a pool, execute it. Okay, fine. The pool will be executed by workers. It's spun up using PCNTL. That's all fine. One of the biggest problems that I have with it is all of these things, they rely on speeding up processes using PCNTL. It's great. Doesn't work in CGI, right? Doesn't work with PHP FPM. So it's very, very unfortunate, but it's all kind of very CLI focused. All of these libraries, their paradigms are very CLI focused. Well, it's not that they're CLI focused, but like, if you compile a FPM version of PHP, it's not going to have PCNTL. They're mutually exclusive. So there could be scenarios where you need that same parallelism, but you need it to happen inside the request response lifecycle of your application, right? So in other words, what you return to your API consumer, you need that result before you can return it. You can't return them something else. You need the result of these API calls, or maybe you just need them to complete so that you can know, was it a successful operation or not? What do you return? Do you return a 2xx, 3x, 4xx, 5xx, whatever else? So this is really annoying. This is this kind of like tyranny of the PHP was built as a CGI language, that you will typically have like an Nginx thread tied to a PHP FPM thread that's executing your code, and it's kind of within the confines of that thread model, and there's not that much you can generally do, or is there? Yeah, this slide is just to check if you guys are following what I'm saying. Does everything make sense so far?
I didn't know that FPM and PCNTL were mutually exclusive. Can you have both of them running at the same time?
Nope, it will not compile with both, in fact.
What's that?
I don't know, but I suspect it's because if you're executing in a CGI thread, it's too complicated to do process management. Like if imagine you have 10 FPM threads, 10 FPM worker threads. What then happens if one of those threads wants to spin up other threads? Like I think it's deemed too complicated to deal with by the PHP team. It's probably a security thing as well, but in my opinion, that should be up to the developers more so than the language. But yeah, that is kind of an interesting thing. If you didn't know, that is the case. But yeah, let's move on and see if we can do anything about this. So the first idea, which is maybe not so fascinating, but it is something that you can do, is that you can return quickly and then just continue executing, right? So imagine you've made a number of calls, API calls. You're using your SDKs, but it's still blocking, right? So what do? You can return while those things are happening, and you can finish executing your operations within the FPM thread. That sounds confusing. That's because it really is. But yeah, so essentially what you do is you return some kind of a promise to your API consumer. This is a little bit dangerous because it comes with like 10 other problems, but you could do it. So for example, if your consumer is creating an API resource, right, you could return the UUID of that resource. You could insert it into the database, continue doing whatever it is you need to do, return the UUID. Yeah, you could possibly use queue workers. So this is a situation where you can delegate it to queue workers, but it still might take 5 seconds or 10 seconds. Maybe your client's partner, whatever else says, sorry, this is too long. Like, all right, fine. We'll give you this thing straight away. I promise it will work eventually. So this is essentially what this solution is. It avoids blocking the request response for too long. You could, so I actually tested this yesterday. You can definitely do it with request middleware. If you're wondering what am I talking about, so request response middleware, it has a certain function called terminate, I think. And this function, it runs after the response is sent to the client. So you can actually do a whole request response, and you can still run code after that, which is amazing in theory. However, yeah, so the problem is it's good for the API, API consumer client. Problem is two problems actually. Number one, it still ties that FPM thread, so it's still not available for the next API consumer until you finish the operation, which is still going to take a while because all those calls are not synchronous. And the second problem is, okay, your API consumer, they might actually want to use this thing immediately before you finish your operations. So you're kind of creating other problems that you have to solve. So, but that's something you can do. It is literally something that works. I was very surprised. I didn't realize it was possible to still execute PHP after you send the response. Oh yeah, and this is like a very, and I was surprised how simple it was to do this as well. It is literally this simple. So you can execute a code even though it's in an FPM thread in a non-blocking way, and then you can here wait until it actually finishes, let's say, but you can send the response anyway to the client. I hope that makes sense. It's a little bit weird, but it does work. It's a bit hacky, don't get me wrong. I'm not saying I recommend you do this, but it is something that you can do if you want.
We use that to like send emails after the request is completed. Like if you're sending email notifications to users midway through a request, and then we like essentially pull those emails, and then after the response has been sent, you send the email pull, and that way if the request fails halfway through, you're not sending out notifications of something that hasn't actually happened.
Oh yeah.
The request is finished.
So that sounds like a perfect use case for this. Yeah, this is just an idea I thought of.
It also looks like
I don't recommend it. So essentially, yeah. So this is a situation where you might not want to store the data that you want to execute anywhere. So for example, maybe it wouldn't be compliant to have it stored anywhere, like it's against some kind of regulations, which is a situation we actually do face. However, you can pass it around let's say the container, the server where you're running, that's fine. Okay, so you can have your FPM thread in that same container, Docker container or Kubernetes pod. You can be running like a PHP server, like an actual CLI server. You can pass the data to the CLI server via sockets, just normal sockets. The CLI server can asynchronously process whatever it needs to do. It can return the result to the FPM thread. It's going to be way quicker. However, the problems, well, so it's kind of really hacky, very, very hacky. I think it will probably cause unpredictable workloads because you're kind of bundling multiple concerns in the same hardware, like in the same pod. It's going to be a little bit difficult to scale, as in load balance scale. There could still be a problem in the server process, and it's like, how do you handle, error correction here? It could potentially be a sidecar container in Kubernetes as well. That might be a better way to do it, but it's still kind of unnecessarily complicated, in my opinion, infrastructure related. But yeah, this is just a diagram I found online. Ignore the fact that this is Node.js, pretend it says PHP. But it would be exactly the same, right? You have web workers. They use sockets to connect to like an event loop PHP server. It does whatever you want, returns back the result. So it is, I think it's very doable. It's just, I don't know. I think the risk reward is questionable. So yeah, what else can you do? So somebody mentioned fibers. So I think this is essentially heading in this direction. There is potential, well, there is an alternative. There is definitely a way to do it now. So I don't know, does anybody use Octane? Damn it, I was really hoping so. I was really hoping there would be one. So honestly, this is the number one problem that I have, not with Octane, but like, I don't know how reliable it is. I don't know, because I don't know of anybody that uses it. It's really annoying. Try and find documentation online, there's almost nothing. But okay, this thing exists. If you haven't heard of it, it's like a Laravel thing, but I'm sure that other frameworks have something like it. And I have no idea how to pronounce this. I assume it's pronounced wool. I was thinking maybe it's like swoole, or I don't know. Anyway, so what is this? This is like, imagine this as a replacement to PHP FPM. It's not the only one. There's also other ones like Roadrunner, which maybe you've heard of. All right, maybe not. Anyway, these tools are very, very, very recent, like the last few years, maybe even, I don't know, 2 years. I'm not sure. But basically, they get rid of PHP FPM. So we're no longer in this thread model. there is still an Nginx thread that comes in, but this thing, essentially, it's like a CLI event loop, right? So it's not any kind of web server. It's not running in CGI context at all. It's just a CLI. So we have PCNCL within the process, which is really useful. And it is an event loop. It preloads the framework. And the original use case for this is not it's not to run threads, but it's actually like super fast. If anybody ever tells you PHP is slow, show them benchmarks of Octane, and they'll absolutely shit themselves. It is incredibly fast. So yeah,
So maybe it's got the framework more ready for the next request. So everything's instantiated.
Exactly.
ready to go, and then the request comes in and then
Yep.
gives it to it.
It is an active process which handles the requests without shutting down the framework or the process between. If that makes
Yeah.
sense.
it's essentially PHP
It's got an
FPM.
entry point with slatering the.
Yeah, imagine like the server, like PHP FPM, as though the whole application was inside it, right? So the whole application is inside it. It's all preloaded. It creates a new, let's say, instance of it or memory pool. Every request coming in from your proxy, like Nginx, for example, uses that application code, executes, returns. So it is actually absolutely crazy fast. However, that's not the only benefit, right? Because we're running in CLI context, with Swole in particular, when you spin it up, like, you know how FPM, it has workers, right? So you can define a worker pool. It can be like on demand. You can do fixed. You can do load balance. With Swole, you actually say, okay, I want X workers, like 20 workers, and which is probably fine because, like, in reality, you want to fine tune the number of workers according to the resources of the infrastructure. However, it also lets you say, okay, I want like, can't remember what they, oh wait, no, it's here. Yeah, they say task workers. So you can have main workers. They process the actual requests and responses. Task workers, think of them as like auxiliary workers. They're not doing request response stuff, but they're there if your application needs them. So then your application, you can actually use lightweight worker threads to do something like asynchronous IO, for example. And you can just use them within your application, literally inside of a request response lifecycle, as though you're running in CLI effectively. And under the hood, yeah, it uses PHP fibers. So I think that's really cool. And all this is there and it's available and you can use it now. And it sounds really amazing. I have not experimented with it, I'll be really honest. But it is something I definitely want to be doing some R&D on before the end of the year because it just sounds amazing. Sounds like everything I've ever wanted. Yeah, so you can spin up these lightweight workers, and they're separate to the ones, so they do not interfere with the actual worker pool that's doing the request responses, and you can just use them as is. Potentially, you could run at the limit of the task workers. You could increase it again. I think the problem there is how do you manage the infrastructure resourcing, right? I think that's really the only problem that you're going to run into. Yeah, but at least, yeah. So in Kubernetes, you can fine tune it at a baseline, and you can say, okay, it can push higher. So it is doable, I think. Again, probably requires a lot of experimentation. But yeah, this is, in my opinion, this sounds like the best, like the most proper solution for this problem of everything that I've done research on. And it does allow you to literally do asynchronous PHP programming within a request response lifecycle without having to use queues. Not that I'm saying this is a replacement for queues. Queuing is still fine. But if you have a situation where you need to do something like you can't afford to delegate it, maybe you can't do anything with the storage, maybe you need the results straight away. I don't know. This is a way to do it, which just didn't exist previously, in my opinion. So yeah, I think that's really, really interesting. And if I guess it seems like nobody here is using it, I would say, look into it and see if you can run your application on it. Again, I don't think it's Laravel specific. Like, this thing is just an alternative PHP, an alternative to PHP FPM, right? So it can run anything, any PHP.
In the chat, Jade Edward said that they think Michael Durinder converted his then pinging service that he runs to Octane.
Oh yeah, that's already posted that and stuff.
Yeah, so it might be someone you could reach out to as well for some more stories.
Yeah, for sure.
On,
I
on
would,
the PHP
yeah, in
Australia
fact, I would love it
Slack server.
if there was somebody to do a talk on this one topic and like I don't know, some pitfalls, some gotchas, like whatever else. Because I really feel like the only potential problem with it is just there's not enough information on it. There's not enough people using it to really say, you know, how reliable is it really? Like we know PHP FPM is reliable. People have been using it as the default for I don't know how many years. It's been like 10 years. I'm not sure, 8 years. This is not the default for anything. So that's one of the problems. And it probably never will be. I'm not sure. But I think there should be more eyes on it. I think there should be more people experimenting with it. And that's really the only way to lead to adoption. Oh yeah, Octane example. So yeah, imagine this is like your request response lifecycle. So you can just say, okay, concurrently do this and this and this to all of your API calls, SDK code, whatever you like. It's potentially very simple. Yeah, you can, like in this case, you're actually doing DB queries as well, which I thought was very interesting. So you can run multiple queries at the same time. That might sound really great. I don't know if the database server will feel the same, but it's certainly interesting. Yeah, so basically this is towards the end of the talk. Conclusions, if any. So yeah, asynchronous paradigms, they kind of continue to evolve. The last time I looked at this was, I think in 2019, at the end of, I think we had Laracon and we had a PHP conference as well prior year. So it was a very interesting couple of years, and I think it was gaining a lot of traction at that point. I think there's been a lot of progress, and obviously like libraries have become disused, which is interesting. I guess that's always a risk. Like anytime you try to use something new, it may just kind of go away. So you have to be prepared to take that risk. But yeah, there's new things happening as well. There's PHP fibers. Obviously, it's really good to see people are doing something with it. It is something that's not necessarily for application developers. It's more for SDK and framework developers, and it does seem like it is being picked up, fibers and coroutines, so that's really good to see. Yeah, we have well, as I just said, we have a long way to go in terms of establishing like really comprehensive documentation best practices, especially for this Octane stuff and you know, fast PHP runners. So yeah, it's really important to find the correct way to integrate these things. You know, what are the best? It's not enough to kind of make it work. Like we have to know what's the best way to run it on this infrastructure, in this infrastructure, in this way, right? Whether it's Kubernetes or something else, doesn't really matter. But I think that's where there's a lot of missing kind of documentation, and maybe not documentation, maybe just experienced people that can teach other people about it. Cool. Yeah, so thank you very much. This is the first time I'm doing this sort of talk, so let me know if you think I've missed something that you would be really interested in, that you think belongs in this presentation. Please let me know. Or if something is particularly boring, you can let me know as well. So yeah, I do appreciate feedback. Yeah, thank you. Thank you very much.
I'd like to see you talking the next BrisPHP of how you trialed Octane to production.
Yeah, I think it will definitely happen. It's just a matter of when. Yeah, but for sure, like it seems like it's the way to go.
There might even be a talk request on the BrisPHP about SWOOL something as well.
Pretty sure there
Something
is.
about quarter 4
How does
this year.
Sure. Yeah.
Something
Could be
really,
after
really
your talk
soon.
or.
It might have been. Yeah.
Doesn't React PHP do asynchronous things as well? I don't know how that really works though.
Yeah, it does. So React PHP also does an event loop, but it doesn't do the whole preloading PHP, preloading your application into the event loop. So I think it's like not an alternative. Like React PHP has a ton of different features for different use cases. It's not like one thing. One of those things is like essentially Node.js, but in PHP. One of those things I think is very similar to what I said in terms of running like a server alongside an FPM worker. So it has a lot of different things. I know people do use it. Never met them, but I'm sure that people, I'm quite certain that there are many projects using this. But yeah, I guess on one hand, it's a little bit sad that even something like that, it's been around for a while. It's not used that much, but I think one of the reasons is it's very like specific use case. Whereas, for example, Octane, like its biggest sell is just the performance, right? Like imagine you could 100x your throughput. Like that's insane. It's absolutely amazing. So like that's a really big draw card, which maybe or hopefully will get a lot of developers to use it. I guess based on this, for maybe it's not working well enough. I don't know. I mean, we're not using it either, but I think we should be. Yeah, I think it just takes a lot of time. Like I was looking, one of the ideas I had is to do a presentation on how to do PHP and Kubernetes correctly. And I thought, well, there's probably no point doing it because probably it's been covered to death. But I actually couldn't find a single like comprehensive bit of documentation anywhere. Like all I found is a very, 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 very basic tutorial. And I thought, how is it possible that Kubernetes has been around for so long and nobody's written about this? Like this Octane is even newer. So yeah, this is like the biggest problem, like the lack of people trying to use it and writing about their experience. So I guess we need more of that, is my point. Yeah.
One thing for the queue, like we found that with the event and listener on the Laravel framework, it's been quite a bit good to help people to like increase the code readability. Like basically like the chicken diagram you had, we could actually know what kind of listeners are actually following like certain events after it's been triggered. So we found that one is pretty helpful for us.
So
Like event listeners.
Yeah, they're basically dispatching a queue, like a queue job as well.
Yeah.
With a lot of new.
Yeah, that's a good point.
Yeah.
There's a job failed listener event, and there's a job succeeded, and all sorts of stuff that passes context around.
Yeah. I just kind of take job for granted, but like say in Laravel, there's a lot of concepts which are job-like. Like there's a whole thing like interacts with queue or something. Like there's event listeners, there's also notifications. I think there's commands maybe, I don't know.
Commands.
Yeah. So there's just like all of these concepts that can be treated as jobs kind of, but sometimes like you don't get the full set of features, like it's a bit funny. So yeah.
Because we used to have a lot of places calling the jobs like dispatcher jobs randomly. And then whenever you want to find, okay, where are the places?
Yeah.
It's like has hundreds of the usages on one single job. But after using this kind of like event listener, we start to have like a better understandings of what's actually under the hood.
Yes. So it's almost like you're explicitly documenting where you're queuing jobs by using that event listener by the sounds of it. Yeah. I think one of the it's really funny because I think one of the really, really interesting things is where do you draw the line? Like when should you queue a job? When should you use an event listener? When should you use like a model event listener, which is like separate to the main event listener? And I honestly sometimes have thought about this and I don't have the answer. I think it's like should you even mix them? Should you not mix them? I don't know. It's an interesting topic, maybe even worthy of its own talk, actually.
How really critical stuff. So, like for example, someone changes something with a timesheet and it needs to go into a draft payslip in our system. Like that is the most critical process that our whole system does, and we can't afford to have out of order bugs or anything, when we can't afford to miss any updates to a pay slip, otherwise someone's potentially getting underpaid or overpaid. And we've flipped a lot of those jobs around so they're all item potent, or however you say it. And instead what we do is we push to a log, which I know then you're effectively recreating a queue, but just bear with me.
Sounds like a ledger. Sounds like what you're describing is a ledger.
You're pushing the versions as they come in, and then when you come around to process it, you just take the latest version of whatever that is. You go, I need to process timesheet 1000, and there might be 4 events that have tweaked 1000, and then you go and mark them all as done in one fell swoop. And so you are reducing the amount of times you're actually processing those timesheets if multiple sequential edits come through. So for example, when you're tweaking things with approved shifts in our system, you go and edit. It's very common for someone to edit it and go, oh shit, I changed it wrong. I'll change it again. And then I'll edit and then I'll decline it. And if you process them in the wrong order, you'll accidentally remove it or not remove it or whatever sort of thing.
Yeah.
And so we'll have several edits that'll come through from the web request really quickly from the user clicking around. And we need to do them all as one version. And if anything else comes in over the top while we're processing that version, we want to go around again and actually reprocess it.
Yeah.
Does that make sense?
Yeah. I mean, it sounds interesting. Yeah.
It's a bit like that, yeah. But it's very specific to deal with that out of order thing and also not to over process it. Because if you do the way it used to work, we used to process every single one in order, but then you're doing so much extra work when you could be batching that up sort of thing.
And it's like the context is in the job, and because it's not 5 folks round robin, one job that was dispatched 2 notes earlier will process first, and the last one goes after.
Yeah.
As well.
Yeah.
That's also a huge factor.
So that we only do that very rare occasions, like for like the absolute critical workloads that cannot fail.
Yeah. But that sounds very interesting. You could maybe do a talk on that even. Like I think
I just
in
did.
wait, where was that?
No.
That was the talk. Yeah.
The other thing that I'd add too is like having a way of it failing in the UI that the user can look at is a good target. Like, so where before when you said like, oh, well, I don't really want to be disturbed, so I'm going to go ahead and send some business person in my same business.
Exactly.
You just offloaded the same work to them.
So we have
push it back to the UI in some fashion.
100%. So we have exactly
Yeah.
yeah.
Doesn't understand it.
I mean, we kind of have this event system which is super complicated. It's not exactly the same as yours, but I think it's the same principle because we kind of want to like for an event, there's a whole bunch of I don't know, let's say it's kind of like a more complicated Jira between 2 statuses. There could be a lot of events. What we want to do is exactly that. We want to make transparent to the business stakeholder who's using the UI what's happening. Like maybe this event fails, this one succeeds, and based on a lot of different rules, maybe it's still okay for some events to fail. But like they want to know. They want to know what's happened with that. And right now it's very non-transparent why these things fail. But that's exactly what we want to do. We want to have some kind of a pretty UI, probably using WebSockets because it is a process that'll take a minute or so. But essentially display every one of these things and say what's happened, why did it fail. I think that's really, really useful. And this is also a problem we have. Like we have these people coming to us saying, hey, this status transition failed. Why? Okay, it requires investigation. Terrible. Ideally you would have a UI in every situation where somebody's bothering you with something. You have a UI for them to actually see why it's failed or succeeded or what else happened. Maybe some interesting thing happened. I don't know. But that's exactly right.
It was a good talk.
Yeah, thank you. Very, very nice meeting you guys. Very nice being here as well. It's my first time kind of presenting in Brisbane.
Thanks for making the trip up as well. Hope you
No
enjoy
worries.
fresh air.
Yes. Well,
All right, so that concludes tonight's meetup. But thank you to the 5 people who submitted BrisPHP.com/pizza. We have a winner. Tonight's winner is Stephen. You get the JetBrains voucher. There's none more fun than actually pizza. Cool. We'll be in touch through meetup again if we can put together ones for the end of the year. Otherwise, there'll be details about that. Tech drinks, Camp.js, for those who are interested as well, was first weekend in November, I think it was. The other one that happens as well, like the first weekend of December, is BDD, which is a community-led one. The ticket's usually like $50 as well, so like a cheap one that runs on a Saturday, so you don't have to get time off work and all sorts of stuff. It's all community-led, so if you want to talk, it's a really great place to talk at. But you also vote on the talks as well, so it's kind of like shaped by the community is what I want to say.
Except the community is mostly right C# with changes.
Yeah, that's right. We can
So good luck
put
getting PHP talking.
Can I ask how many people come to the tech drinks? I've never gone to that one. What's the vibe there? Does anybody go?
I've been a couple of those.
Yeah.
There's like, it's lots of people, really, like.
Lots of introvert people.
Yeah, but everyone's on the
Looking at their
board.
shoes.
Everyone's on the
Tech
board,
drinks,
mate.
bro.
So you get,
Like,
yeah. Go along. It's definitely, it's a good time. There's free drinks if you.